Hello and welcome everyone to our second of 4 sessions where we will learn from experts in applying complexity methodologies in research. You can learn more about our sessions by clicking on the link in the chat. My name is Joey Eisman, and I am a doctoral student at Temple University and the graduate student representative for the Complexity Theories in Education SIG. The purpose of the SIG is to apply, advance, and extend complexity theories to inquiry, research, theory, and practice in a variety of educational contexts. I am pleased to be joined by Dr. Helene Pennings. Dr. Pennings is an assistant professor in health professions education at the University Medical Center in Utrecht and an educational scientist at the Netherlands Organization for Applied Scientific Research. When doing her master's in behavioral science at Radboud University in Nijmegen, she first learned about dynamic systems theory and state space grid analysis. Little did she know that during her PhD, she would get more involved in complex systems thinking and using methods like state space grid analysis, spectral analysis, and orbital decomposition to study interpersonal communication education. Currently, she's working on projects related to learning analytics, supported personalized learning and adaptive expertise, and reconnecting with research and interpersonal communication that she can study this in the health professions context. A majority of our session will include Dr. Pennings' presentation. And if you have any questions, I ask that you please post them on the Jamboard, which we're linking in the chat, and we will share with Dr. Pennings as time allows. So please now join me in welcoming Dr. Pennings.
Thank you, Joey. I will share my presentation. Let's see, I'm not used to Zoom, we use Teams, so I always have to search for where, here, share screen. This one. Good. You can see the screen? No, probably not, because I needed to press share.
We can see the screen.
Now you can. Okay, now I have to move the Zoom to another screen. Yeah, here. Sorry. Yes, good. So welcome everybody. Like Joey already mentioned, my name is Helene Pennings, and I will talk to you about my research using state space grid analysis. And like last webinar where Dr. Daniel Russell provided an explanation about time series analysis, state space grid is also sort of a time series analysis method. So first I would like to take you to this, well, this is sort of a voting tool, and I would like to ask at least one question at the moment, but then I will return to this a few times during the meeting. So if you could go here, then I can share my first question. So you can change the language settings at the settings menu, because I was aware that this is all in Dutch, but I couldn't find a change language, default language. So the question is, who learns more and why? Just think about the why. You can click one of the pictures to make a choice. So Joey, is it possible that people unmute or not?
Okay, I believe anyone can unmute.
Okay, great. Sometimes they blocked it for people. So I would like to hear if someone would like to share their reasons for their choice. So if you want to share, just unmute and explain. And then I will
define-
later.
Sorry, I define learning at the level of the group, not the level of the individual.
Okay. Someone else?
If I may weigh in here, I believe that in this context, we can see that there are the kids and the teacher engaged with one another, and they're basically, I think, are trying to learn by doing something. So that's why I think it's the most constructive way of teaching among these four.
I agree. I think we've got a lot of engagement and activity, and I also look at learning as a group activity, but one that's really tied to interactions and engagement, and that fits with that bottom right picture.
Okay. Well, thank you very much for your ideas about this. I agree with all of you completely. So interactions are really important for education and for learning. Also making it a group activity and learning from each other is like really important, and we know that it really helps with learning. Although my correct answer is that all of them are learning. But it's difficult to state who learns more, because everybody has their own learning preferences, but also in time things change, and culturally there's also a lot of differences in how people think about education and about learning. But thank you very much for this warm up. I will talk to you about the classroom as an interpersonal dynamic system. So what we know from the theory is that humans are individual dynamic systems, and interactions between humans foster development. For example, relationships between students. And I borrowed this graph from Tom Hollenstein, who used this. I'm not sure if he made this himself, but I think it's a really nice representation of how individuals in classrooms and outside classrooms could be related to each other. So on the micro level, we have these individuals. And then on the meso level, the interactions between these individuals in a classroom or in a small group. And then on the macro level, there's like these larger systems, like multiple classrooms that are in schools. So what we usually say is that relationships between people and how people develop is nested in multiple systems. And also that interactions develop over time. So in real time, from second to second, but also from hour to hour, from week to week, and within years and over years, development still takes place. So what we often see is that this nestedness in time is forgotten, especially in educational research. And I'm very happy that we have this SIG and that there's much more attention for this dynamic systems theory and complexity that's involved in this in education and in classrooms. What we do assume is that these interactions are necessary also for teachers to improve their profession and to develop as a teacher. So that's actually how I started my PhD research on this topic. I wanted to help teachers who were beginning and were struggling, to give them some like guidance on what to do. So it started from a group which studies interpersonal theory, interpersonal communication. And a lot of how this works is that the teacher behaves in a certain way in front of the classroom. And based on this behavior, students form an opinion, a perception of this teacher. based on their behavior, but also on how they are themselves. So what they find nice or not nice. And these interactions that follow, this is a sort of a continuous action reaction sequence. In the next slide, I will have an example of this. When we combine all these perceptions of these students, we can describe sort of a relationship that they have, and we now call this the interpersonal style of the teacher. So this is what we study on the macro level, and what we see on the micro level is all these behaviors that the teacher shows and that also the students show. So this can be seen in this next slide. So because it happens on multiple time scales, we can see that interactions that start off, first, if you meet someone, you are friendly, you're trying to get to know each other. This is also the case in teaching. And then throughout the first lesson, the first few weeks, these interactions start to evolve, and then somewhere they stabilize into like patterns that are sort of prototypical for the relation that the teacher has with these students. And that's for us, that's the macro level time scale, like description of the quality of a relationship. And one could say that like these interactions are on micro level are the building blocks of relationships. So that's what that's the context that we are studying. We use interpersonal theory to conceptualize, operationalize this interaction study. Interpersonal theory is mainly rooted in personality psychology and clinical psychology, but also already since the 80s, Theo Webels has started his research on interpersonal theory. He then used the Leary framework to develop a model for interpersonal relationships in education. So this provides the framework and the concepts for us to describe perceptions, behavior, interactions between people, and interpersonal styles. So I will go a little bit into this before I go into the state space grid analysis. So interpersonal behavior, people cannot communicate when they are together in the same room. It doesn't have to be verbal, but non-verbal people can also communicate with each other. And there's a lot of words that can be used to describe how a person is behaving interpersonally. So these are a few examples. And according to interpersonal theory, these behaviors can be ordered along a circle, like similar words like closer together, and opposite words like further apart, like friendly and mean. They are very far apart, but friendly and understanding are very close to each other. And where in the circle these words lie depends also on two dimensions called agency and communion. So agency is actually like dominance versus submission, and community is friendliness versus hostility. And people always show both at the same time. So that's someone who's leading shows both communion and agency. Well, then we have the another principle from interpersonal theory that's really important to to describe interactions between people, because how interactions develop depends on the complementarity principle. So this states how people adapt to each other. So what we see is that people who behave high in agency, they will elicit behavior low in agency of the other person. So it's a bit of a weird example, but at the moment I am talking, I'm explaining to you, and you all are listening, and you're not interrupting me. So that's actually, I'm then more agentic, and you are, well, submissive to my talk at the moment. Also, another part is the complementarity on communion, which actually states some kind of sameness. So if I'm friendly, then you also will react friendly to me. If I'm hostile and I'm like, well, like previously with this question that I asked you, and I would say, well, this is a really weird answer that you gave, then you would have thought, well, Helene, you can say everything you want, but you are not a nice person. I will leave this webinar. And luckily, fortunately, you didn't leave the webinar. So I hope this means that I was nice to you and being understanding for your question. So that's actually what happens when, well, when complementarity on the communion dimension occurs. So this is an important principle in education. To study this interpersonal communication, we developed 2 interpersonal circles, one for teachers and one for students. They are here presented, and the words surrounding the circle are sort of prototypical or anchor words that we use so that people understand what types of behavior are located where in the circle. And these circles can be used to describe micro level behavior as well as macro level interpersonal styles. And I will show you how we do that next. So to describe interpersonal styles, we have a questionnaire, which is called the questionnaire for teacher interaction. And we always ask students to answer this questionnaire for the teacher. And then based on the answers of all the students in one classroom, we can identify the location of the style of a teacher that the students perceive. One should notice that people can have different interpersonal styles in different situations. So a teacher can have a different style in classroom A than in classroom B. And it all depends also on the interactions that they have with each other. So that's actually this micro versus macro level, and these building blocks that interactions are of these perceptions of students and the styles that they give to teachers. So for the educational context, we have identified 9 styles, one for each of the octants of this circle and one in the middle. The names of these styles are the same words as the anchor words that we used, except for the one in the middle, because there's no anchor word. We call that struggling, because these are often teachers that really struggle and not exactly know what to do. So they change a lot in behavior, from hostile to friendly, from submissive to dominant, but it's really unpredictable. And from a large body of research conducted over the last 30 years, we know that directing and helpful are like very positive for student outcomes and also for teacher well-being. And that we also, well, I go make all the colors right now. We also know that the imposing and understanding styles are somewhat okay-ish because students still learn. But especially with the imposing style, you see that students actually work hard because they're afraid of the teacher. So we can wonder whether that is what you want to establish. And then the red ones, the 5 other styles, are really not beneficial for learning, but also not for the teacher themselves. So we see that many of the teachers, especially with the struggling, dissatisfied, and uncertain styles, that they drop out of teaching as a job. So to study micro level interpersonal behavior, I used the continuous assessment of interpersonal dynamics method, which is also called the joystick method. So here's a joystick, and I will show you shortly how this works. There's a program behind it which gives you this screen, which, well, resembles the interpersonal circle, except that it's in a square, but we always try to forget that. You can play a video besides this screen and then move this joystick while you are observing the teacher or the student. So what I did was make a video from the back of the classroom where I could observe the teacher, and a video of the front of the classroom, which was pointed towards the students, so that I could also observe the students very clearly. So I have a really short going to pause the video here. So this was a really short demonstration of how we did this. This is not a video that I recorded. This is just a really old video that we could use for the purpose of this demonstration. So I coded all my videos with 2 people. I've known studies where they used more coders, but we thought our reliability among coders was sufficient enough to proceed with well, the codes that we had. So after we finished this coding, we converted these scores, like there's coordinates coming out of these data, and we converted these to the octant score so that we could analyze them in state space grids. We did this using a vector-based method. There's a lot of research about this, so I'm not going to go deeper into this, but it's a really nice method to calculate the angular position of the behaviors in this circle. So I have another WooClap question, so I will move the, if you still have the app open, then that is okay. So I'm going to do a sort of a joystick training with you. This is the first assignment that you receive when you do the joystick training. I will give you a few words, and then I will ask you to position this in the circle where you think this belongs. So the first word is warm. Okay, so I'm going to show you the correct answer. It's here, but I just put it around the area where it is, but at least it's on this side, so that's a warm communion. So the next one is cold. I'm not sure actually whether you already put these answers in, but it says you can no longer vote. Can you vote this one? Ah, okay. Well, hostile is here. Sorry, cold is on that side. Maybe it's because I put the answer there already. Yeah, that's it. Okay, so this was like a trick question for you. Oh, here's another one that's already given. Okay, then I'll go through it much quicker. So unsociable is here. Next one. This one's working. I tried this out with colleagues, so maybe that's what happened. So trusting. Okay, I will give the correct answer, even if not everybody answered. So it's actually down here. But I've seen this a lot. But actually, when you are trusting people, you're putting your trust in someone else. So you are less dominant, so you're more submissive. So that's an explanation. Okay, next one. Passive. Great. Well, this is correct. Well done. So I actually have a few more, but given the time, I think I will move on to my next slides. Well, actually my next questions, because I think oh no, I did. Yeah, I did. So I wanted to ask, who of you has heard of state space grid analysis before? Maybe I can push results and then, yay. You can still answer, right? Good. So nice to see that there's also people who haven't heard of it. I hope you will be able to follow my presentation, but if things are unclear, please ask them in the Jamboard, and then we'll try to, I'll try to answer them after the presentation, and otherwise maybe you can contact me and then I'll answer any questions that are left over. So who has used it before? Oh, nice. The majority hasn't used it. I just realized now that I should also have asked who wants to use it, but I didn't, sorry. So thank you for your answers. I will go to the next slide, because now I will go into the state space grid stuff. So state space grid analysis. This is a method that was developed in 1999 already by Lewis, Lamy, and Douglas, sorry. And they developed this because they needed a complex dynamical systems method that could process child-parent interactions. So there wasn't any method that could do the analysis that they wanted, so they built it themselves. They also built the software. The dimensions underlying a state space grid usually consist of categorical observations of behavior. So they can be both ordinal and nominal, as long as they are mutually exclusive. So actually a state space grid is a sort of a graphical representation of observations that are, well, of independent observations, but that are coupled in time. I have a small example of a trajectory that's moving through the state space grid here. And often the opaque node is used as the start of the interaction, so that if you look at state space grids, then you will know, okay, that's the starting point. And from there, I need to follow the lines so that I know how the trajectory was going. Except this is a really small example, so it's easy to see. This is not always the case, as you will see later on in the presentation. This is the program, the gridware, that is used to do the analysis. You put the data in, and then you will get this screen with the well, the state space grid in the middle, On the left, there's a box that says filters. You can choose which trajectory you want to show, because you can put multiple in there at once. So you can also compare, for example, 2 or more trajectories with each other. You can set colors to each of the trajectories. We will see an example of that later. And on the right, there's a screen with like grid measures, which I will explain more about. So you can, I don't have an example of this, but you could select a cell in this grid, and then the grid measures will appear. So then you will see how often the cell was visited, or how large the nodes are, also shows how long the visits were. That's all. You can all see that in this grid measures section. So how do we go from 2 trajectories to 1 grid? I hope that this visualization helps a little bit. So on the left, there's this teacher interpersonal circle with the trajectory of the teacher. In the middle, there's the class trajectory. So you can see that the teacher moves from the directing octant to helpful, back to directing, and then to oh my God, I forgot the name, but to a more strict behavior. And for the students, you can see that they start like really submissive, and then they move up a little bit more to a little bit more dominant behavior, and then go back to submissive. So in the right, there's a state space grid, and you can see that the opaque node is in the cell that corresponds to directing of the teacher, so the left column, and it starts in the reliant octant of the students. So it's a combined location. I will point it here. So this is the reliant octant, and this is the directing octant, and together they will be displayed here. So then the teacher becomes helpful, but the students remain reliant. So this can be seen is that there's a change in teacher behavior, but no change in student behavior, but the cell shifts because the teacher behavior changed. So this is how you go through this trajectory. You can see like combined behaviors. So what is a state space grid? So it's a range of all possible behaviors that can appear in interaction. So that's what I explained earlier, is that the categories have to be mutually exclusive. So everything that someone shows should be possible to put in one of the categories. And what many studies do is they focus then on the content and on the structure of trajectories. So the content actually describes which behavior is shown in interactions. And this is often described by identifying attractors, like the behaviors that the interaction is pulled towards, or repellers. So that's like the cells where the behavior doesn't come. That's behavior that doesn't occur in interactions. And then there's also a structure. That is how behavior unfolds in time, which is indicated by these grid measures, like the number of transitions. So how often does behavior change? But also how much the behaviors are scattered across the state space grid. So that's described by dispersion. And then there's entropy, which is sort of indicator of predictableness of interactions. So a little bit closer to content. Mainly attractors are identified to describe the content. You can do this with two methods. For example, looking at the perseverance, that's the mean duration that the interaction remains in a specific cell. Or you could use the winnowing procedure, which is more empirical, which relies on an iterative process to eliminate cells with the lowest durations. They do this by calculating the heterogeneity score. I will not go too deep into this, but it's an example of this is on this screen. Yeah. So here's per cell. This is an example of Tom Hollenstein. This is per cell, the duration. I think it's in seconds. Well, let's say it's in seconds. And then there's, based on the observed and the expected time in the cells, you can calculate a heterogeneity score, which is provided here. And then this is a proportion is calculated. And then they say that the cells after the largest drop of about 50%, which is here, are the cells that most probably are the attractor cells. So sometimes it's just one cell, but sometimes it's also multiple cells. And if these are adjacent to each other, then there's, well, that can also be called attractor regions. So then we have structure. There's like 6 measures, number of events, a number of visits. That sounds the same. I don't have an example here actually of, these are all events, but sometimes you have 2 consecutive visits in the same cell, because that depends also on how you operationalize your data. And I'm now a little bit sad that I didn't put a good example in there because now I cannot explain this really well. The other ones are average duration of visits. This can also be seen by the size of the nodes. So the duration in this cell was much longer than the duration in this cell. This was really short. So there was a really short behavior change. Or this one, this could be an intervention of the teacher, like, hey, come on, listen, and be a little bit strict for like 2 seconds. And then that would be a visit to this cell, but then you would move back to being friendly again. Like I said, the dispersion is the scatteredness around the state space grid. So here you can see that there's a lot of events here, and there's one more here, but the scatteredness is not that big. I will show you an example of a very scattered state space grid in a minute. And then there's visit entropy, which is the predictableness of the interactions. So if there's a lot of changes between cells, a lot of small nodes, then this affects the predictableness of behavior. So I will now show you 3 studies that I did during my PhD. The first one is published in Nonlinear Dynamics and Psychology and Life Sciences. The second one in Teaching and Teacher Education. And the third one in the Journal of Experimental Education, which was a special issue that was edited by Grant Marchand and John Hilpert. So I was really happy that I could publish in that special issue. I did that study with Tom Hollenstein, who was one of the state space grid gurus for me. So the first one was really exploratory, because we didn't know how we were going to include student behavior then yet. So we only studied teacher behavior. So what we did was we combined teacher agency and teacher communion together in one state space grid. And we were just wondering what are differences in content and structure, and how does it differ for people with, well, teachers with different interpersonal styles. So we use this joystick method. We compared 8 teachers, 1 teacher per octant. So we didn't have the 9th interpersonal style at that time. So there's just 8. Let's see, there were differences in subject, and some were men, some were women. Teaching experience ranged also from beginning to more experienced. We couldn't control this, like make sure that it was all the same in teaching experience, because generally people who have a lot of experience are not in the, well, less positive interpersonal styles. Sometimes people just have to develop through working. So this was what the state space grids for these teachers look like. And what we saw, they are ordered like this is if you start with directing the first directing the first octant. This is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th in the interpersonal circle. So this teacher interpersonal style was characterized as with high agency and relatively high communion. So in this octant, and you can see that the behavior of this teacher also resides in that part. So teacher B was his behavior was characterized by high levels of communion and relatively high levels of agency. And also we saw that the behaviors that we observed were mainly in that area. So as you can see, well, at least for these 2 examples, what we found regarding content was that the correspondence between the location of the attractors and the states and the behavior that we observed in the micro level interactions, that seemed to be quite high, except for 3 teachers. And these were teachers with low levels of communion and agency. So that were these 3, I think it was D, F, and E. Maybe it was, well, at least I haven't described this in my notes, unfortunately. So that was a nice start for us to study interactions with state space grids. We also looked at the grid measures. We only selected 3 of them: number of visited cells, duration of visited cells, and visit entropy. And what we saw that for we did a Spearman rank correlation because it was a really small sample, and we saw that the interactions of teachers with lower levels of communion were characterized by higher variability and less predictability, and that teachers with higher levels of communion showed lower variability and were more predictable. But we didn't see this for agency, so only for communion. So we actually concluded that communion was very important in interactions for developing a good relationship. Okay, I will skip this one because it's actually just what I said in the other slides. So the second study was the first study that we did with also including students. We just wondered, we chose a teacher who had a less good relationship and a teacher who had a better relationship with students. And we wanted to see whether the grid measures and also the content could discriminate between these 2 teachers. Well, I already said this, 2 teachers with 2 different styles. And here's the example of the state space grid where I used colors to code the teachers. So the teacher with the, well, I have to check, with the less good relationship is the one in blue, and that's teacher B. And then there's the teacher teacher A, and then the teacher with the better relationship with students is teacher B, which is presented in yellow. So what we saw was that teacher B was, teacher A, sorry, I'm a little bit confused now. Teacher A with the less good relationship had lower communion, because there was, well, the communion was more to the left, and the teacher with the better relationship had showed more communion. And in agency, it was a little bit similar, except that the teacher with the less good relationship showed a little bit more agency than the other teacher. So, and what we saw was that there were differences in situations that we studied. We looked at the lesson start, a negative situation and a positive situation, but we did not really see differences overall. So we did see that there were differences in the negative situation, especially. So I will go to the next slide. So this is the last study that I did with Tom. We looked at 35 teachers. We wanted to see whether this interpersonal content was related to their interpersonal style. And we also wanted to see whether the structure, especially the structure measures, were different for teachers with good relationships and teachers with less good relationships. So we call them less preferred and more preferred relationships. So there were 35 teachers, all varying in experience and in subjects that they taught. Also student age differed, but it was all secondary education in the Netherlands. Female, male was a little bit, well, was not the same, but it was divided quite well, I think. So what we saw, this is all interactions combined. I left the lines out because it would not be possible to really understand what was happening because of all the blue lines that were showing then. And we can see that a lot of interactions are located here, which means high teacher agency and friendliness, and also student friendliness, because it's on the left, right side of the interpersonal circle. These cells are located. This right state space grid shows the number of times that a cell was identified as an attractor. So for 16 teachers, cell 1-4 was an attractor. So which means directing teacher behavior and relying students' behavior. Let's see. Then we have this this difference between most preferred and least preferred teacher interactions, and we see that in the most preferred, a lot of behavior is located here, and we see a similar tendency also, of course, in the less preferred interactions, because most teachers who are struggling or dissatisfied, they still have good interactions with the students throughout the lesson. They're not dissatisfied all the time, but you can see that there's much more nodes lying in the mutual, actually, dissatisfied and critical section. So much more than in the most preferred classrooms. So what we did, don't read this. You can see all this in the article if you want to. But we showed for every teacher what the grid measures were and what the results were for agency and communion, which were the attractors. I think that's in another table. So what we did a Kolmogorov-Smirnov test to test whether differences between most preferred and less preferred teachers could be found. So what we saw was that there indeed were significant differences, especially in the number of transitions, the number of cells, the number of changes, and the dispersion across the grid. What we thought was interesting was that visit entropy was not significantly different, because from our previous more exploratory studies, we thought that teachers who had less good relationships were less predictable for students. So this is quite surprising. And what we also saw in this study, was that again, communion in the micro level was important, which was also a result of one of the earlier studies. So these were the three studies that I conducted myself in my PhD and my postdoc. I have a few examples of other studies. I would like to go through them quickly, so I will not be that elaborate then of my own studies because of the time. I did one, I was also involved in the next few slides. So this one was of Tim Meinhardt. He was a PhD student in my team before me. So he started with this and I followed up with my studies. And he also looked at complementarity. So for example, the black line here is perfect complementarity, and he wanted to see how complementarity could be shown in these state space grids. Then another study that we use as one of the examples in our book chapter in complex dynamical systems in education, which was edited by Matthijs Koopmans and Dimitrios Stamouvlasis. This was actually one of my first studies that I did to explore when we didn't have a interpersonal circle for students yet. We thought maybe it's interesting to look at student on-task, off-task behavior and whether it's passive or active. So this was the yellow part is a sort of section that we were most interested in. I didn't follow up with this one, so this is the only thing that we described for this study in this handbook chapter. So then there's a lot of studies done. Some are recently, some are somewhat older. So one is in dyadic communication. This study just uses it as a illustration of how you can analyze interactions. Oh, yeah. So then there's a study of Elisa Kupers. She's from Groningen here in the Netherlands. And Paul van Geert, you might probably know him. She studied scaffolding patterns and autonomy support of teachers using state space grids. Oh. Then there's Meinecke et al. They used state space grids to study team interaction. So like, for example, teacher teams. I have a few colleagues who, for example, work with studying not lesson study, but communities of practice. And then, they could use this to analyze their interactions and to see whether this can discriminate between teams that are more productive and unproductive. That's what this group also did. And there's another one about dialogic reading and whether interactions and the type of questions that teachers ask, whether that is different for students depending on their reading comprehension level, and which students are more prone to answer questions than others. So there's a lot of applications. I will not go into this. And Julianne Turner, she studied student engagement and motivation, and how well, teacher motivated behavior could help students' engagement. So there's a lot of different types of research that can be done. It doesn't really have to be interpersonal theory related. It can be like on motivation, or even other things can be studied. So here's some references. I will show it really shortly. And then this is my last slide. So thank you for your attention. And if you want to know more about state space grids, then here's a QR code to the website of, well, it's now Tom Hollenstein's, but it used to be of Lamy and Douglas. So thank you.
Thank you so much, Dr. Pennings. If you wouldn't mind, stop sharing your screen, and I'll share mine. I think we'll have time for
Great.
maybe 1 or 2 questions. And then as possible, hopefully maybe we can have the rest of them answered offline.
Good.
So here we go. We actually have a bunch of questions that came up. I'll let you kind of decide which ones are you're most interested in and which ones we can probably save for another time.
Yes. Yeah, so one of the questions that I see is like, can state space grids be done with continuous data? So officially they say it's not, but actually my data are continuous. When I code them, this yields a continuous stream of data, like every half second. I didn't mention this during the presentation. But we converted this to categories, and then also to like events, so that we didn't have a node in the state space grid every half second, but we sort of, well, we converted our time series to be able to use it in state space grid analysis. So it is possible, but it depends a little bit on your on the data that you have, I think. Do participants struggle with the joystick method? So it's not the participants that use the method, so it's observers who are trained, but it can be difficult to start off with the training. So it takes about 8 hours of practice, I think, before you really manage to do this right. Doesn't averaging collapse the complexity of the system? I'm not really sure about which averaging is referred to here. It is true if you, like I did in the last paper, where I looked at group means and just checked whether these were significantly different from the other group. So indeed, that does a little bit collapse the complexity of the system, or at least looking at complexity theory, but it's just it doesn't rule each other out, I think. So we did also really go deep into the work of I'm sorry, I was a little bit distracted by the answer, the question in the chat. But we averaging doesn't rule out that you can also look at the individuals and the complexity of each system. And to react to the question that was popping up in the chat. So I do know Nienke personally, so she's a colleague. So I do know her work. I just made a selection of a few studies that I thought were interesting to share here.
Well,
okay, so you you removed the screen, so I think the time is up.
I think I want to respect everyone's time. I also, thank you, Dr. Pennings, for all of for your rich conversation, your discussion of the variety of applications, and also more also how you have found stage-based grades to be useful in your own work. Maybe
Thank you.
possibly we'll find a way to answer some other questions offline, and we'll share that as it comes out. So thank you so much.
Yeah,
I
you're welcome.
also want to share that I encourage everyone to come to our next session, which is going to be Wednesday, March 8th at 7 p.m. Eastern Time, where Dr. Jonathan Hilpert will present on social network analysis. And I will drop the link for registering for his talk. There you go. Well, thank you everyone for attending. Thank you, Dr. Pennings, for your presentation today, and we'll see you all soon.
Thank you all for coming and for your nice questions.